So wave equation, so we are talking about this, right? So that is your electromagnetic waves. So this is your electric field, this is your magnetic field, right? Ex is given by E naught is equal to sine. Usually what we will be putting? Be sine omega t, right? So we are going to put omega t, but in addition to that there is one more term here. Kz minus omega t. And Bx. So if I take this as z, right? This as x, right? That means this must be your y value. So that means Ex values will be given by this equation. So for example, look at this. So depending upon this position, right? This amplitude will change or the E value will change. This will be dy. It will be d naught sine kz minus omega t. So far we have seen only omega t. Now why are we saying some kz minus omega t? Any idea? What is kz? What's that? X-axis, okay. Z-axis. So it's a bit hard to imagine, so think about it. So is the wave going to be standing there like that? No, it's keep moving, right? So that means this part will be moving here. This part will be moving here. So it keeps on changing, right? So it changes with z, it changes with time. So there are two factors, it's not just one. Okay. If I draw a line like this, in your mathematics you can say, okay, as z changes, let's say this is x. So as z changes, x also changes. So that means I can write an equation using x in terms of z. But then with respect to time also it changes, right? It's not going to be the same. Which means after a certain time it's not going to be here, it's going to be here. Following what I'm saying. So that means it's not going to be one single term, it's going to be two different terms. Okay? So we don't have this derivation, but you just have to understand that there are two terms which it depends upon. You may get some numericals based on this. This is important, so please listen here. What is omega? Omega is equal to angular frequency, right? So this entire thing, what do you think? Inside the sign, what do we put? We put some angle. So what is the unit of angle? Radians, right? So the entire thing should be radians, right? So that means this should be radians, this should also be radians, right? So if this is times seconds, how can I convert it to radians? Omega is equal to 2 pi by t. I'm sure you have studied this, right? That 1 by t becomes the nu, 2 pi nu, right? Or 2 pi m. So omega is equal to 2 pi by t. So what will happen if I multiply by time? Time cancels. I will get 2 pi, which is your radians. Okay, so depending upon the time, the radians will be different radians. Following? So this is angular frequency or angular velocity. K, we have a special name for that, wave vector. So I told you z is nothing but location, right? So which means how do you measure this location from here to here? Do you measure it in kg or meters or seconds? Location. Location. Meters, right? So that means this will be a length unit. Okay. That means I should put something very similar to this, but I should not put the time. What should be in the bottom? I should also have the same unit as meters. multiply 2 pi by lambda with position, you will get radians. Are you following? So this is 2 pi by t, this is 2 pi by lambda. So this is called magnitude of A vector. So they are given a small relationship here. If I calculate omega by k, right? So what will happen? I will get 2 pi by t divided by 2 pi by lambda. So 2 pi cancels. So I get lambda by t. This is 1 by t. 1 by t becomes lambda into nu frequency, right? 1 by t is your frequency. So what is lambda into nu? C, velocity. So that means omega by k is equal to lambda nu. So lambda nu is nothing but c. So that means I can write it as omega by k is equal to c. So that's a small relationship. So it comes under wave equation. They may ask you to prove omega is equal to kc. Something like that. You should know this. What is z? Z is a z-axis, right? So the location. So what it means is, so please listen, as you told you, we are not talking about how we got this, but at a given point of time and at a given location, if I want the E value, I have to tell, okay, 5 meters from here, what will be the E value? After 5 seconds means I have to put 5 seconds here, 5 meters here. So depending upon the time and such, the E value keeps changing, right? So it's going to go like this. So that means I can use this formulas to calculate the E value also. Okay, so it depends upon the location, it depends upon the time. Okay, so make a note. So E value one small derivation and then we're almost done. But, okay, if you have space in your previous notes, just go back and take it down from the previous class. I forgot one small thing I have to talk about it. Very often let me ask you this. So when we talk about the capacitor thing, right? So if you have some space there, there. So if you have the capacitor, the topic here is capacitor. If you don't have space, then you can take it down separately. You know that it goes one B unit capacitor and its direction. So if I take this as a plus plates, right? This as a minus plates. So which way is the electric field? Plus 2 minus. So the electric field is going to be this. So you all know this. But which way is the magnetic field? I told you the other day, if you put a magnetic compass, right, it will reflect, right? Even though there is no current, it reflects. So what was the explanation given by Maxwell? displacement, current, right? So even though there is no current, there is some kind of changing electric field. The changing electric field causes the magnetic field. Okay. So here I told you if you take a loop like this, right? So again, if this is a capacitor, the loop is like this. Okay. So in 2D, this is the best we can draw. Okay. Perpendicular. So loop is perpendicular to the paper. So listen carefully. So if the electric field, so again all these things are 3D, okay, so if you don't understand this, it's going to be very hard, it's very simple. So this is one plate, this is one plate, so this is plus, this is minus, so the electric field is going this way. Suppose if I am seeing it from here, it's going into the paper, so that means I am going to say, so if I show this electric field, I am going to say this is into the paper, so electric field is into the paper. If that is the case, right, the magnetic field direction will be circular. So meaning, you remember the very first experiment we did was when you have a current flowing in a conductor, how is the magnetic field? Magnetic field is in a circular path, right? So that means very similar to that. The magnetic field is given something this. So remember, usually we show this into for magnetic field, but here it is electric field, okay, not magnetic. So it's into the paper. So if you take this line here, this is your magnetic field direction. So any idea, is it going to be this way or this way? Clockwise, why? Because right hand thumb rule, so very often it will be right hand thumb rule. So if you use right hand thumb rule, it will be going like this. So the magnetic field is this way. Okay. So right hand thumb rule. Okay. So this alone I missed it the other day. So this comes along with that capacitor circuit. So as I told you, the first part, that Maxwell's theory is a little bit high level. Okay, so at least the basics you should know. Okay, whatever I put as plus, you can skip it. But again, go through your Arihant. So if they ask, then you have to study. Otherwise, you can skip it. Okay. But if you are aiming for more than 90% or something, you have to study everything. Okay, you cannot skip it. So the magnetic field, you can show something like this. So this point it's like this. This point is like this. This point is like this. This point is like this. Okay. So this is given page 272. Page 272 in your book. So go back and read that. Of course, the Maxwell's theory is extremely difficult to read in your book. Okay, so whatever I have given, I think it should be clear. Okay, so there is one small theory. So whatever I am going to give you, right? So I will put some boxes. So those boxes or the formulas is given in your book, but the derivation is not given in your book. Okay. So, but still, sometimes it's kind of confusing. We don't know what they are expecting. So, take it as a plus, but at least the boxes you have to remember. So, intensity is equal to power by area. Power is nothing but energy by area into time. So, whenever I put a box, you should know this. Okay. So, that's no way you can see that. Electric field in the capacitor, right? In capacitor. So, what is the energy in capacitor? Half CV squared, right? So, I told you many times the easy way to remember is half MV squared for kinetic energy, half CV squared for capacitor, half Li squared for inductor. Okay, so three things if you remember it's easy. So this V is velocity or what is this? Capacitor voltage, which means you have to draw a little bit, write it a little bit there. So C, how can you write in terms of A and D? Epsilon naught A by D. So V, how can I write in terms of D? Victory is equal to education. So that means E square, D square. So DD cancels. So what I will get is, what is area into D in the case of capacitor? So I am talking about the capacitor here. It looks something like this. So this area into this distance, what will you get? Volume. So that means A into D becomes volume. So half epsilon naught volume E squared is your UE. So if I bring the UE on this side, UE by volume is equal to half epsilon naught E squared. What do you call this term? We have studied this somewhere else in your second chapter. Energy density. Divided by volume is energy density. Energy, so let's call it as, since it is E, what is E standing for? Electrical energy, electric field energy. So electric field energy density. Okay. So this side I am going to write for inductor. So in inductor, what is the energy? Magnetic energy, half Li square. So as I told you, derivations are not very clear, whether they expect you to study it or not. When you go through again, probably it will become clear. Okay. But these formulas you should know. It's not nice. So what do you mean by inductor? It's nothing but a coil solvent, right? So inside the coil, what is the magnetic field? B is equal to mu naught by N9. So B is equal to mu naught N9. Somewhere in your EMI chapter, I think we derived expression for L. Just like C is in terms of epsilon naught A by D. For L, we derive something like mu naught N mu naught small n into capital N into A. This can be also written as capital N by L. Okay, so maybe we have different forms of this. I, how can I write I here? I square can be written as B squared divided by mu naught squared N squared. So mu naught cancels, N cancels. This capital N I am going to write as N into L. So one more N can be cancelled. Right? Number of turns is nothing but small n into L, right? So I'm sure you remember this. N is equal to capital N divided by L. So capital N is small n into L. So number of turns per unit length is your small n. So again, what is area into length? Volume of the solenoid, which means I can say 1 by 2 volume. So this into this becomes volume, this becomes V square. That is some volume volume. So if I bring the UV on this side, UV volume is equal to 1 by 2 V square by okay. So definitely they ask a lot of questions in your entrance exams based on this, okay? Because this is the areas where it's not very clear or it's kind of very vague. The book will ask you more questions. So this is electric field energy density. This is magnetic field energy density. Again, there is one more. So let's say we told electric field is generating the magnetic field is generating the electric field, right? So that means this energy is getting converted to magnetic field's energy is getting converted to electric field, right? So that means the energy density of this should be equal to this one. That means I am going to say UE by volume is equal to UV by volume. So this is half epsilon naught. Again, try to see the similarity. Okay, if you see the similarity, it's very easy to remember. You have half epsilon naught E squared. Whenever you have epsilon naught, the mu naught will be in the reciprocal. So that means here epsilon naught is the top, which means mu naught will be in the bottom. Here it is electric field, so you put E square. Here you put D square. E square is equal to 1 by epsilon naught mu naught V square. So C is equal to 1 by square root of mu naught epsilon naught. So this is another relationship you have to remember. So this is nothing but C square. That means it becomes E is equal to C. Okay, so this is an important derivation. I mean, all these derivations not given in your book, but all these equations are given. Okay, so you have to remember all these equations. What is the meaning of this? E naught is equal to C B naught. Amplitude of E is bigger or B is bigger? E is bigger by 3 into 10 power 8 times. So it's a huge difference. That means the diagram which we have been drawing is very, very centimeter, this is not going to be 5 centimeter, it's going to be very, very smaller than that. So the p is going to be extremely small, like 3 into 10 power 8 times smaller. Okay. Just for understanding, we have been drawing it like that. You understand what I'm saying? We don't follow that. So the amplitude here is E naught. The amplitude here is your V naught. But if I try to show 3 into 10 power 8 smaller than this, you are going to see nothing. Right? So you cannot see anything that small. Any idea how we got this? Anybody remember what is the value for mu naught by 4 pi is equal to 10 power minus 7. What is 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. So mu naught by 4 pi is equal to 10 power minus 7. 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. So maybe I will rewrite this mu naught by 4 pi is equal to 10 power minus 7. If I divide this and this, I will get 4 pi cancel. This will go over here. So 1 by naught epsilon naught is equal to 9 into 10 power 9 plus 7 16. Right? What is 9 into 10 power 16 look like? Square of C. Right? 3 into 10 power 8. So I can write this as 3 into 10 power 8 the whole square. 1 by mu naught epsilon naught. That means this is true. So I can say C is equal to square root of mu naught epsilon. Again, I'm sure they are not going to ask you these derivations, but you should remember this. If you see the derivation properly when you are studying the equations, it will make more sense. Okay. So what I expect you to do is study all this theory, okay? Study the notes first. The plus marks, maybe you can skip it, go back and study your Arihath also, okay? And when can we have the test? So mainly I am going to ask only from Arihath, not even the sheet which I given you. This sheet will help you to go through the chapter, okay? So it will help you what all things you are supposed to go through it. So that